Something is shifting inside the EV industry right now. Not on the surface, not in the showrooms or the press releases, something deeper. Something that most people haven't noticed yet. Elon Musk recently mentioned a rare earth-free motor, and the headlines treated it like a footnote, a cost-cutting move, a technical update, something for engineers to argue about in forums. But here's what those headlines missed. The entire electric vehicle industry, every motor spinning inside every EV on the road today, is quietly dependent on a group of metals that come from a handful of places on Earth, and the countries that control those places have more influence over the future of transportation than most people realize. So when a company the size of Tesla starts talking about eliminating that dependency, this stops being a story about a motor. It becomes a story about control, about who builds the future, and about what happens to everyone who isn't ready when the ground shifts beneath them. But this only matters once you understand what's actually at stake, and that starts with something the EV industry almost never talks about in public. Every electric car you've ever seen, the quiet acceleration, the instant torque, the smooth, silent pull, all of it depends on a motor. And inside most of those motors are permanent magnets, small, powerful, and almost invisible, made from rare earth metals with names most people can't pronounce. Neodymium, dysprosium, elements that sound like they belong in a science fiction novel but are, right now, holding the entire EV industry together. These magnets are the reason electric motors are so efficient. They maintain a constant magnetic field without consuming energy to do it. The motor doesn't have to work to create the field. The field is just there, always. This is what gives EVs their edge, that smooth, responsive, energy-efficient performance that made people fall in love with electric cars in the first place. But here's the part that doesn't make it into the marketing materials. These metals aren't easy to find, they aren't easy to mine, and they aren't spread evenly across the planet. Rare earth production is concentrated in a very small number of places, which means that the supply isn't just governed by market forces. It's governed by geography, by politics, by decisions made in government offices thousands of miles from the factories building your car. And if supply gets disrupted, if exports slow down, if mining stops, if a political decision gets made that has nothing to do with electric vehicles, production slows, costs rise, and every automaker in the world feels it at the same time. This is the hidden vulnerability at the heart of the EV revolution, and almost nobody talks about it, because from the outside, everything looks fine. This is where the story starts to get uncomfortable, because this isn't a new problem. The industry has known about this dependency for years. And for years, the answer has essentially been, keep sourcing the metals, manage the relationships, and hope nothing goes wrong. Tesla actually tried to break this pattern early. The original Model S and Model X didn't use permanent magnet motors. They used induction motors, a completely different design that generates its magnetic field electrically, without any rare earth magnets inside. It was a bold move, and it worked up to a point. Induction motors proved that you could build a fast, powerful EV without rare earth dependency. Tesla demonstrated that convincingly. But induction motors came with a trade-off. They were less efficient. They consumed more energy to do the same work. And in an industry where every percentage point of efficiency translates directly into driving range, that gap mattered. So the industry drifted back toward permanent magnets. Better efficiency, better performance. The trade-off seemed worth it. And for a while it was. But here's what that drift also meant. Every company that followed the permanent magnet path built their entire architecture around it. Supply chains, manufacturing lines, motor designs. All of it optimized around the assumption that rare earth magnets would always be there, always available, always affordable enough. That assumption is now being questioned. When Musk talked about a rare earth-free motor, the obvious reading was cost reduction. Remove expensive materials, lower the price, move on. But there's a second reading, and it's more interesting, because eliminating rare earth dependency doesn't just change what the motor costs, it changes what the motor is. It changes how it works. And if the approach Tesla is exploring does what it appears to be doing, the motor stops being a fixed hardware system and starts becoming something closer to a responsive, software-driven machine. Here's what that means. A permanent magnet motor works because the magnetic field is always present. The magnet does the work passively. The motor just uses it. But if you remove the magnet, something has to replace that field. And the direction Tesla appears to be moving is toward generating that field dynamically, electrically controlled in real time by software. Think about what that actually means. The motor's behavior is no longer locked into the physical properties of a piece of metal. It can be adjusted, tuned, optimized on the fly. Torque delivery, field strength, energy consumption, all of it managed by algorithms. Responding to what the car needs in that exact moment, the car looks identical from the outside. The performance feels the same, but the internal logic has completely changed. This is the hidden technology inside the rare earth-free motor story, not just a new material. A new way of thinking about what a motor is. But this is also where the hardest question lives. Permanent magnets are efficient precisely because they don't consume energy to maintain their field. The field is free, in a sense. It's just there. But a dynamically generated field isn't free. It has to be created electrically. And creating it costs energy. In an EV, energy cost means range. Even a small efficiency loss can translate into fewer miles on a single charge. And range is still one of the most important factors in whether someone buys an electric car or doesn't. So the central tension here is real. Remove the magnets, gain supply chain freedom, but potentially sacrifice the efficiency that made permanent magnet motors worth using in the first place. This is the knife edge the technology has to walk, and Musk's claim that the new motor can match performance without the rare earth dependency is either one of the most important engineering achievements in the EV industry's history, or it's a promise that's going to be very difficult to keep. What bridges that gap, if anything can, is software. Smart real-time control systems that manage the motor's field dynamically, generating only what's needed, when it's needed, and pulling back when it isn't. Not a constant field, a precise one. If the software is good enough, the efficiency gap closes. The motor becomes as capable as what it replaces, and the rare earth dependency disappears. If the software isn't good enough, the range suffers, and the entire proposition falls apart. This is what the industry is watching, not the announcement, the proof, but assume for a moment that it works. Assume the engineering holds, and the efficiency gap closes, and the rare earth-free motor scales into production. The first company that feels it won't be a startup. It'll be Toyota.NBYD and every legacy automaker that spent the last decade building their EV strategy around permanent magnet motors. Because here's the position they're in. Their supply chains are optimized for rare earth sourcing. Their production lines are built around permanent magnet motor architecture. Their designs, their testing, their manufacturing relationships, all of it assumes that these metals are central to how an EV motor works. If a motor system emerges that delivers comparable performance without any of that, their existing infrastructure doesn't become slightly less competitive. It becomes a liability. Changing motor design isn't like updating software. It means redesigning production lines, rebuilding supplier relationships, re-engineering vehicles from the drivetrain outward. For a company that builds millions of cars a year across dozens of markets, that's not a pivot. That's years of disruption and billions in investment. A smaller, more agile company can change direction faster. A legacy giant is moving a ship the size of a city, and the window to change direction doesn't stay open forever. The longer-term impact reaches further than the competition between automakers. Today, EV adoption is still largely concentrated in wealthy countries. High vehicle costs, infrastructure requirements, and supply chain complexity have kept electric transport out of reach for much of the world. The rare earth dependency is part of that cost structure. Not all of it, but a meaningful part. If that dependency breaks, if motors can be built without sourcing from a concentrated, politically sensitive supply chain, the cost floor drops. Not overnight, not dramatically at first, but directionally, it moves. And when the cost floor drops, markets that weren't viable start to open. Fleet operators who wanted to electrify but couldn't justify the numbers start to recalculate. Delivery networks, taxi fleets, logistics companies, the math starts to change for all of them. The developing world, where affordable Reliable transportation is still one of the most pressing practical problems people face. Moves closer to something that was previously out of reach. This is what a supply chain shift actually looks like at scale. Not a better spec sheet. A different map of who gets access to the technology. Here is the full script. Something is shifting inside the EV industry right now. Not on the surface.